Hello, everyone. Welcome to the SIG Node meeting on September 9th, 2025. Starting us off, we have Kevin.
Hi. Let me present my screen. Okay. I think you can see it now. Yes, awesome. So my name is Kevin. I'm currently working on enabling pod-level resources with the resource managers. That includes topology manager, CPU manager, and memory manager. Well, basically, it would be to bring the same benefits that currently the CPU manager and memory manager have for allocating specific resources for the workloads, and also getting help with the topology manager to choose a better topology for the corresponding workloads. To get started, the main point for this meeting would be to get an agreement on what the behavior of the different topology manager scopes should be. For overall, the feature would be basically support the topology alignment, hint generation, and also the allocation of resources for CPU and memory with pod-level resources. I think that that summarizes in general, but I would really like to focus on the behavior for both the scopes. Currently, we have container and pod scope in the topology manager. With pod scope, basically the hint generation takes decisions with the overall set of containers within the pod. So basically, if we set pod container, when the hint generation will try to get topology that allows us to get all our containers together. And then if we use the container scope, then our containers can be separate. For both scopes, the allocations looks kind of similar. We actually end up with similar results because the proper methods for allocating it obviously focus on the containers, and which we end up with the same kind of behavior, just depending on all of them together in the same, for example, in the same socket and NUMA node, or in different NUMA nodes. Starting with the pod scope, we have our current behavior that all the container resources have to be set. So basically have guaranteed quality of service, specify the request and limit. Well, in this case, we offer alignment and exclusive location. And now we will be allowing two new cases. The case where only pod-level resources are specified, obviously also with a quality of service of guaranteed, without any of the containers being specified. And then this one would be pretty much straightforward because the pod-level resources would be the ones to be used and the only ones available to take decisions about. And then we could also have the case where pod-level resources are being set at pod level and then and container level too. And here, there could be multiple approaches, and it depends on what ultimately be the goal or the use case. With what we have seen is that we have two main paths. The first one would be to basically ignore container resources, since we are focusing on the pod scope. And in this case, we would only take the alignment for the overall pod using the pod-level resources, and then the allocation would be obtained that from that topology for that CPU sets, basically sent to the containers. So if we get a pod that requests 6 CPUs, those 6 CPUs would be aligned the same way for each container. So basically, the CPU set would be repeated for each container that belongs to the pod. And also, we have the other option, which would be more dynamic, we could say. And we also make use of the pod level resources, take the whole CPU shared pool. This will be the same case for memories, I'm just mentioning CPUs to make it simpler. But we could also specify the container resources and take those into consideration. The thing here is that currently the quality of services focuses completely on the pod level resources if they are present. So if we want to take a dynamic approach of considering both levels, we would have to make that same check if we want all containers to be set. And the actual use case that we think it's beneficial, for example, ML workloads, would be to actually specify just for a single container. That single container will have different pool of CPUs that still belongs to the overall pod, but will not be shared along the other CPUs. So for example, if we have a CPU that requests we have a container that requests 2 CPUs, and then we have another 2 containers that doesn't have any request limit, and then we have a pod that requests 6 CPUs. Basically, that container that is specified will have 2 CPUs reserved just for them. Those 2 CPUs would be part of the overall pod pool, and the other containers that didn't specify would have the remaining CPU set shared pool. And those 2 containers that didn't specify will have the same CPU set. Do you have any doubts for this scope? I will going to proceed with a container scope. Yeah.
So there are some scenarios where this alignment between multiple containers in one pod is not really valuable. Example for that is telco kind of workloads. So you have one pod, you have 2 containers. First container is the data processing part. So it should be aligned at CPUs and PCI bus closest together. But when the second container is kind of infrastructure container, like logging and whatever, so those better to be placed on our CPUs rather than close to this PCI bus. So we need to be careful in those scenarios.
Okay. That case would be considered for option 2. Just the thing that you're mentioning that it would be actually in the same NUMA node. Do you mean in regards to the topology, or do you mean like exclusivity of the CPU usage, for example?
Let's take a simple scenario. So you have like 2-socket system. On the first socket, you have network cards. So
Okay.
all the data processing containers needs to be on that socket. And everything what is not using network cards, it's better to be placed on another socket.
Do you think in this case it would be better to have both the containers specify requests and limits, or are you saying that in this case only pod level requests and limits would be set and only one container has requests and limits set?
This infrastructure container might have like some small resource request and limits, or might not set at all. Well, probably it will be set, but some small amount.
Yeah, I mean, if both containers would have requests and limits set in this case, then that would be out of scope of the pod level resources, right? It's just how the current behavior would accommodate for this one. And I think there is a policy where you can have CPUs allocated from different sockets if that's the requirement.
Well, Dixie, what I'm talking about is third line in the table when both pod and container resources are set. So both of those options, assuming what we are trying to group them as tight as possible. And in my example, it's not really valuable.
But are you saying that both containers would have requests and limits set in this one, or only one container, like in the example?
Well, both. Like the network container will have, let's say, like 5 CPU requested or like 4 CPU requested, and the infrastructure will be just 1 CPU requested.
Yeah, then that's out of scope of pod level resources then, right? Because both the containers have requests and limits set. That scenario is already tackled by scope equal to container, and I think there are a few policies that can help
Yeah.
allocate CPUs from different sockets.
But I think, Dixita, if in case that you don't set the limits and requests in the container and you have set the pod with guaranteed and you have two containers, the one is infrastructure and the other one is network, then in this case, from a performance point of view, it is not recommended. You will underperform. I think this is what Kat tries to explain here.
Yeah, I'm still trying to process that. If in this case, you're saying that if in this case both containers don't have requests set and only pod level requests are set.
Correct.
Right.
Then you have guaranteed, as I understand it, will respect the topology, but then your both containers will actually, even if not needed, and the one container is more important to be closer, the other one, the sidecar, will be like a penalty. And the other solution, someone might thought then, okay, let's split it in two pods, then make the one guaranteed and the other one not guaranteed. But in this case, you have to consider of interpod latencies and these kind of things. But this is, yeah.
But sorry, but in this case, which is very valid and very important, but why should the user set the pod level resource limit in the first place if they have this requirement? This is what I'm not understanding.
Francesca, it's not about what it's need to be set. It's what most people will be, well, some people will be using it if it's possible. So we need to have a documented behavior.
Okay, that's very, very fair. But what I'm trying to say is that, okay, if the user has this constraint, which I agree, I see as well, then I don't see what they are trying to achieve, how they are trying to improve the use cases, setting pod level resources. So I agree that, okay, we should document that, but it seems to me that we should guide the user to say, this is probably not what you need, exactly because pod level resources are going to behave in this and that way. So probably this is what I was not understanding. This is the key, probably.
My line of thinking is what pod level resources can be used to limit overall burstability for infrastructure container. So like the network processing container will be guaranteed, and it uses like most of those CPUs. But the infrastructures might be, well, some burstability.
Okay, that's a good point. Last question, and I'm going to quiet myself. Is that something that pod level resources enables or makes more convenient? But because it seems to be we can do that even in the current state of things. Is a use cases are missing? I mean, you can set Yeah, you need to be the math. You need to be careful math with the other container to so the overall pod is guaranteed QoS. Okay, right.
Yes.
Yes, you're right. Yes, yeah, you're right. Now I get your point. Yes, now I get your point. I think we should document that indeed. Yeah, that's for sure. This is right. Yes. I'm thinking if we need a different enhancement in topology manager to really enable this case or not, but for the conversation of pod level resources, yes, this should be clearly documented. Yes, I agree.
Yeah, the purpose for enabling pod level resources would be to mainly be able to have a shared pool of CPUs, also a shared pool of memory. While also considering like a specific container resources, like putting like an example would be this case where we have like a critical workload, and then you can specify that only to that critical workload without having the need for doing it for the other containers, because currently the behavior focuses on specifying all the containers. Like all the containers have to be constrained and specific to the specified resources, the container spec.
But that's fine. But as I'm saying, like there are workloads which benefits to be tightly collocated, and when there are some which benefits from spreading across the system within one pod.
Yeah, I agree with that.
So it might be just option. Well, probably what we're missing, and when we need to have it documented for people to be able to properly use it and not shoot themselves in the foot.
Yeah, I agree with that. I will follow up with that, consider that. I will document that point. For this case, I would like to, before continuing, I think that I would like to try to reach an agreement. Now, putting an example for like a concrete scope example, currently we specify the spec for the two containers that for the Centane pod. The hinge generation for pod scope will focus on the overall pod. We basically get an allocation of each container. And then with the new behavior, we would be basically enabling specifying at pod level resources. One container which could be critical will have 3 CPUs, and then the other ones will not have anything specified. The overall hinge generation would also focus on the overall pod as it currently is being done. Just in this case, the result would be different. For the first container that specifies, we will have that reserved CPU set, but for the other two containers, we will have a share pool. And in this case, do you agree with having a hybrid approach for enabling both levels at the same time, and so we can get like a customizable reserved set of containers, while others are a set of shared pool containers, or just consider the main call-level resources aspect.
So if you go back to a table below, so there's 5 CPUs. So with container 2 and container 3 in your example, is it guaranteed QoS request and limits? So if request and limits are equal for those two, container 2 and 3.
No, here they wouldn't have any request and limit set. The request and limit, the guaranteed quality of service would be set at pod level resources.
In that cases, I'm okay with this.
So
go ahead.
If container 1 has request and limits set to 3, then the hint is fine and the exclusive pool is fine. If container 2 and 3 have only requests but not limits, or well, only limits but not request, then shared pool is fine. But if the request and limits are set for container 2 and 3, then the shared pool is not expected by the workloads.
So that's the first rule in my understanding from the table. Is that true, Kevin? First one. Yeah. Can you highlight that one? So that's the container. The first one, yes, the first row here. Yeah, the entire of the table, first row. So container 1, 2, 3. My understanding, okay, I first time I saw this doc, and the request, every container request and the limit equal to, right? What?
Yeah, well, that's fine. Yes.
Yeah. So in that cases, I'm fine.
Yeah, it would also be possible to have this same use case because you could specify at both levels, but I would say that the user would not actually do that in the first place because you can already do that with only setting the containers. And if you want to use pod level resources, then the point would be to only specify to a certain number of containers.
Okay. May I ask if, in case there are init containers, which limits a request takes?
Init container is different from sidecar container. Okay, let's just focus on init. Shouldn't the init?
I'm mentioning it because we have like if you are going to do CPU pinning and you are going to have guaranteed, then if you're going to have the init containers, I'm just wondering which ones we are going to use. That's what I'm.
I try to answer. We might not different from the Kevin, but that's my understanding. I just try to share my thoughts. So init container is different from the sidecar container. Suppose it can be used in entire of the pod resource, right? In here, because init container is sequential. Once we have the pod level resource, and even before, without the pod level resource, we are basically allow it is used entire of the pod resource by design.
Okay,
but
so
sidecar container we need to think about more. Yeah.
Okay.
Kevin, can you add the sidecar and init container all in here?
Okay.
So one quick question. So in the use case Sasha was mentioning like in row 3, if container 2 and 3, it only specifies request and not the limit, then the pod itself would not qualify as like guaranteed QoS, and like none of the containers would get guaranteed CPUs, right? So basically the pod needs to satisfy guaranteed QoS, and then we check like individual containers, like they need to specify both request and limit or not specify anything. Is that like a fair condition for the pod to satisfy?
Yeah, the pod would be still have the same requirements of having guaranteed quality of service and also requesting an integer number of CPUs. For the containers, it would be the same case. So basically, for the containers that would receive a reserved CPU set, would have to also make the same requirements. It would have
Okay. Okay. So you need to satisfy it like both
Yeah.
levels. Okay.
Yeah.
Thank you.
One general comment which bothers me quite a lot. So in this document, we are talking only about the CPU and memory, but the actual use case is device plus CPU plus memory. And in case of pod, we have the containers which have device access and ones which don't have a device access. And it means what hint generation for each individual container and hint generation for pod and overall might be different. So it might be somehow on the water storm with that.
I haven't considered that yet, but I will follow up with that. Yeah. Yeah. Done.
So Francisco, you raised the hands before me.
No, Don. I already made my comment. Go on, please.
So for this last table you show on the screen, I don't understand the fourth row. What's the difference between the first row from the third row? So are they exclusive options you ask here?
For the fourth row, we have a discussion about supporting or not the case, because since it would be container focused, we would also have two paths that would be not offering any alignment or exclusive allocation, and the other path would be to have the alignment and exclusive allocation, but this would make this will produce inconsistency, because the quality of service will have to basically ignore the pod level resources, would be different than all the other handling across the pod level resources feature. And also another thing that would be kind of problematic is that we will have to constrain it to only the entire, well, all the containers will have to comply with having request and limit, and also the integer number of CPUs, because if we don't do it that way, I think
we have the room.
Yeah, for whatever.
Yeah.
Yeah, right. Yeah.
Yeah.
Okay. So if we need to constrain to all containers being enabled, then it wouldn't make sense for the user to actually use pod level resources. In this case, they could just specify all the containers. And if we only allow for a partial number of containers, in this case, I think would be out of scope for pod level resources, because that feature could be implemented without the need of pod level resources, like allowing only some specific number of containers without having another, with having some others that don't specify, could be achieved without actually the need of pod level resources for this scope. Having partial containers that are specified at pod scope would require pod level resources. So that's the second decision that I have to get an agreement on, like the two options for the container scope and the two options for the pod scope. And in this case, this would be like the first option of the container scope, like not offering an alignment or allocation, but the pod would be still admitted.
Okay, so you are just seeking for opinion, feedback. We should take the the logical, the manager to take the pod scope or take the container scope. Is that your question here? But because from the doc, I couldn't understand what we are asking for here. So
okay.
For pod scope, it makes sense to me from the first table. And also for the third table, you basically just show the comparison between the pod scope and the container scope. Is that true?
Yep.
Okay, got it.
Yeah, I include this one be option 2, and this one would be option 2. Option 1. For the previous approaches. And the thing is that the container is set as a kubelet config, so the user would have to know from the beginning if they want to focus on the container or the pod level.
I'm okay with the pod scope, and I think it's covered. I do agree with Alexandra that I also know there's the one problem we need to put more thoughts on the Setka container, and the init container I think shouldn't have problem, but the Setka container we need. I also agree with Alexandra Sosa earlier mentioned that it's not just CPU and memory. We also need to think about the OS and other things. But I do think about at least based on the table you present here, I do think about and also earlier discussing about the use cases, right? So I do think about the pod scope cover besides those to-dos and cover all the use cases. Yeah.
I have a question. I'm not sure if this is a valid use case or not, but it just clicked to me right now, and I want to see if any of the options can support it. Say there is a pod which has 3 containers. One main app container where we have requests and limits set, while the other 2 containers, just the same example as you have, while the other 2 containers do not have requests and limits set. And I want the main app container to get CPUs from one NUMA node, while the other containers to get CPUs from another NUMA node, so that like there is no noisy neighbor issue in that case. So is this use case supported by any of the options that we have decided or that we have picked here? And if this is is this a valid use case, first of all?
That's the use case what I was talking about.
Yeah. I think I
Totally valuable use cases.
right. So the same use case that you mentioned, is it that the containers 2 and 3 for these 2 containers, we do not know very specifically how much requests these would need, but we know cumulatively how much requests these 2 would need, and they should be on separate NUMA nodes? Or rather, my question is, like Francesca was saying, does it make sense to have pod level resources for this one?
It makes, so when we can have a main application guaranteed container and the rest is burstable containers.
But in this case, okay, I agree about the use case, no question about that. What is bothering me is that in the current resource manager feature set, with the current feature manager, you can allow that, but you cannot request that, hey, I want this packet processing workload on this NUMA node, and I want the other container in this pod on the other NUMA node. I mean, we don't have anti-affinity constraint between containers and NUMA nodes. So yes, it's a valid use case. Yes, pod resource, level resource should take that into account, but I'm not saying someone said so, but this is not something we can implement using pod level resource. It's an enabler, right? It's not that, okay, once it is in place, we can achieve that. We should make sure it's not preventing that, but to actually support that, we need extra pieces, I believe.
Yes.
Francisco is not right, but I see the Dixie point. Dixie point more is like even in the future we add that use cases, right? So but that use cases is have to describe from container plus pod level, both together. Because you basically want to see like there's the container one on the one NUMA node. And then you can ping on that one NUMA node, ping the CPU on that NUMA node, right? So then you have the container 2 and 3 should not run on that NUMA node and intercept NUMA node, but they could share. They could have like a own, but they have their own shared CPU CPU pool, and also excluded other could be like this is large machine and have other work node. So that's kind of cases. If we purely from the pod scope, we maybe cap this situation, right? Yeah.
I think, yeah, from pod scope, if we support only pod scope, then all the CPUs would be coming from one NUMA node, right? In this case. Yeah, I don't know if
See, that one also should be I personally think that should be covered. So the reason it is, I just in here after aspect, because that container one, you are basically have to have all the CPU, right, on that NUMA node.
Mm-hmm.
Right, so then you own not just North level food from the container 2 and 3, any other container, any other pod will view as the loyalty to that container 1 in that cases. So that the container 1 is going to request all the CPU, ping on all the CPU on the NUMA 1. Still, I think, then plus additional of the pool 1. So then end up that container 1 will have the CPU request and the memory. And also additional, which is the Francisco earlier said, we need support that use cases. Yeah, I just think louder, sorry. Sorry, too many hands.
Yeah, is it me? Okay, I have a question to the use case that Dixit and I just said. I mean, if I'm going to have two containers inside the same pod, I assume that the containers speak with each other. I mean, that's the whole idea of having them inside. But then if they are on a separate NUMA, then this means that you're going to have like the latency is going to be higher because you will have to use the different NUMAs caches and all these things. So in that case, I don't understand why someone should do it like this and not just. I mean, what is the benefit? That's what I don't understand. I mean, I would prefer to be in the same NUMA if they are closer and they are interacting. If they are not interacting, then why you should have them in the same pod than just separate? Can you explain, or I'm missing something from your use case?
I can explain it. So like infrastructure containers is something like logging or similar. So amount of the data which is transferred is not the big one. So having it on different NUMA node is not affecting too much of a latency. But take the example of you have again, like two socket system. And on socket 0, you have only like CPU and memory, and on socket 1, you have devices like network, GPU, whatever. So, like the main container, will be having the requests for the device, and hint generation will say like use socket 1 for those. And for all infrastructure containers, it might be like, well, it doesn't use the device, so the hint generation will say like both socket 0 and socket 1 will be fine. So we're currently, because we're taking the decision for each container independently, it's currently possible. As soon as we're introducing the pod level and saying like, well, all the container needs to be tied together, this pattern of usage is not going to be possible. And it's not only about the noise, it's more about like the full utilization of a node. So like in my example, when socket 0 is only CPU and memory and socket 1 together with devices, we want to have to put as many device consuming containers into this socket 1. So it's not about what those like small containers will be producing noise. It's more about what we can pack, let's say, like main applications, which will consume all the CPUs on the socket 1 exclusively.
Okay,
Make
thanks
sense?
for explaining. Yeah, it makes sense now. Okay, thanks very much.
So I had one question about like this row 4 here. So the topology manager scope container is like a node level setting, right? So and now like with pod level resources and topology manager scope container, we're not allocating exclusive CPUs in row 4. But on the same node, if there is a different pod which does not use pod level resources, that would get exclusive CPUs. So are we okay with that like non-uniformity? Like basically, if there is a pod which requests 5 CPUs at container level, it gets exclusive. But if it requests at pod level, it wouldn't get exclusive CPUs. Yeah, based on my understanding.
Yeah, I think in both cases, if you look at it, these two pods are very different. The first one that gets exclusive CPUs, all the containers have requests and limits set. So it's sort of easy to kind of have CPUs pinned with each container in this case. But when it is for the second case where only pod level resources are set and only one container has requests and limits set, how do we pin the CPUs for the other containers that do not have requests and limits set? So I think these are, but again, open to hearing other people's thoughts. These are very different pods if you look at them. So the behavior might be okay to be different.
Yeah, I think if I understand correct, the comment is that this exactly what you described is an example of someone can be confused. So I
Yeah.
guess, yeah. Mm.
Yeah, like on the same node, like some pods would get exclusive CPUs, but like a different pod with a request specified at the pod level would not get exclusive CPUs. So it could be a little confusing. So maybe documenting that is enough. But yeah, just wanted to bring up that point.
Yeah, I think this would require extensive documentation for sure. Yeah, my point here for this entire discussion is I think this is a very complex problem to solve if we think of all the use cases. But yeah, we can maybe try to accommodate the use cases that we have thought and discussed today, and then start with pod level scope in alpha of this feature, and then maybe iterate on it if we and discuss more on it if we need container level scope as well, and or if we need to support more use cases before we do beta. Maybe starting with something will give us more insight into what else we could build in the next iteration. Yeah, Francesco, you have a hand.
Yeah, from my own personal perspective, starting in alpha with pod level scope makes sense to gather initial feedback. There are two concerns, however. The first concern is that if I remember correctly, the new rules for graduation says that when we reach beta, it should be feature complete, tested, and everything. So the only graduation criteria for GA was okay, turn the feature gate, well, change the name basically. So that will mean that we will need multiple alphas which could be fine, but I just want to say it aloud. And the second concern is that what do we do in between? Meaning, okay, pod scope is supported. If you configure with container scope, what happens? Meaning, we get a rejection. It's a question. I'm not saying. And so we get a rejection. We get kubelet fails to start. Anything in between. So this is another thing we should think of.
In my opinion, we should not reject those pods and rather have an event or a log message saying that these pods are not aligned for scope equal to container. Because rejection could be disruptive, but rejection also kind of throws a clear message to the user. So pros and cons. But since this will be just an alpha feature, and I'm assuming not a lot of people would be using pod level resources and topology manager if it's only in alpha. So maybe a log message and an event is okay until we widen the scope in the event in the subsequent releases.
I still didn't convince we need the container scope. Yeah.
Sorry for interruption. I think we may want to give 9 minutes to the next topic. I think we spent quite significant time here. Thank you, Dixie and Kevin.
Thank you.
The next topic doesn't have a name, but I would think.
Yeah, sorry, I forgot to write my name. My name is Radostin. I just want to ask for advice on what would be the next step for essentially for the working group. What do we need to do to kind of move forward? And I'm mainly asking because we received a lot of comments and we're trying to address all the comments. But at this point, we just updated the pull request and we just want to know what we have to do next.
Yeah, I think it's largely getting consensus from all the participating SIGs on the scope and making sure that everyone is aware of the process and has bought into it. So have you done presentations at other SIGs? I know like SIG Auth and SIG Storage were participating.
Yes, we had a meeting earlier today with Adrian and Victoria, and we were discussing exactly this. Essentially, we plan to go to the SIG scheduling meeting next week, and I think we have 5 SIGs for the working group, so we have to go through them one by one.
Yeah, I think previously we were in discussions that we really want to get API machinery to approve the API, so get through API reviews. The question so far, like on container differences, the question is what's the API and how it will be used. So once we know the use cases and how, like we do it in Kubernetes, and it's easier to push through this feature and get it implemented. So I think that API questions will be one of the primary questions, and you can approach it by discussing it as a working group first and then go to API server, or like start with API review, and then once you get initial feedback, go back with more information. But yeah, I think that's a primary. If I were you, like driving it, I would start with API and push for approval for use cases first.
Okay.
I think they have to first understand their use cases, right? So for this kind of things, with the current implementation, only have some implementation on the node, right? SIG node, and also is the container based. So I think it's not just API. You need to tell us in your dreamland and how you are thinking about it. You are going to checkpoint and restore. Is you are going to checkpoint restore entire of the pod, or it's just some of the container within a pod in a different replica container. So that's kind of like a fundamental things you have to figure out. And right, based on the use cases, you are going to figure out those kind of things. Then we can talk about the API. Because right now we are just only doing something like the last couple of years, we are doing something just checkpoint as a tool for the node, right? So for the some different use case. So now we want to make that is like the tool cluster level automation system or tools. We need to figure out the use cases more clear. Because I just read that one. I think it's a little bit arbitrary when people ask a different question. So far, you are thinking about this container, but then once you think container, then you but then there's some other question, obviously from the network side, and the answer are really like the pod. So it's the mix, the hybrid. So then I think about the people having to figure out the use cases here. Just this is a wonderful technology. Oh, let's just go do. But what's the use cases? What's the end-to-end behavior? And then we can talk about API. Because when you talk about API, if it's container-based, API could be simple, right? But if it is the pod-based, and then that's the more SIG will evolve. And also then API need could be API also still simple, but the more SIG will have to involve, like for example, scheduler. No matter what, scheduler will involved, but the complexity level is at a different level.
Yes, we actually have a few different use cases. I mean, I think it would make sense to go through the different use cases and prepare like a proper presentation next time, mainly because we don't have that much time today. Yeah, this is very helpful. Thank you.
But at least the SIG Node sponsor really endorse this one, sponsor this one. We just want this one go fly. Obviously, yeah.
Yeah, thanks. I think this is everything. And Sergey, Peter, do you have any comments about essentially the working group or anything that we, or should we just discuss this next time?
Yeah, I think having concrete proposals just as like a general direction for the working group and presenting that here and then in other SIG meetings, I think is a good next step.
Yeah, thank you.
Thank you. All right, it looks like that is the end of our agenda and also the end of our meeting. So thank you, everyone. See you next week.